Welcome back to Thinking with Objects, lecture number 1, Introduction and Classes. So before the break, we spoke about how to use a class, how to create objects from that class, but we didn't really speak about, well, we didn't speak about it at all, how to write these classes, these blueprints for our objects. So this part of the lecture, I'm going to go through how we can make a die class, and then we can use that to make a dice game or something like that. So, well, let's get started. So we have these two ones here, two different blueprints, and we spoke about the share here. But now it's time to talk about the die, like I said. So that's our class. So let's stop calling them blueprints, because that's not really what they are. They are classes, even though they work sort of like blueprints, but now when we're going to create one ourselves, let's call it a class. And well, when we do so, we simply create that class. So what do we need for that class? Well, first of all, we need a method called roll. We need to be able to roll the die, right? So we get a new number there. Then we want to be able to get the number itself from the die, and then finally want to be able to get the amount of sides the die have. So well, usually a die have 6 different sides, but that's just the normal dies. But then we can have like with 10 or 20 sides, whatever. And finally, when we create a die, we want to be able to set the amount of sides it has, and also give it the random number generator so we can randomize these numbers. Right. So let's get started with actually creating that. So that's what we need, and now it's time to make that. So first of all, we need to type public class die. So that's exactly the same like if we would create a program. So we have the class here, and then we have die there because that's the name of the class, and that's the noun die, not the verb. So first we want to make a constructor. The constructor is a type of method that is being called when we create a new instance of this class. So when we do for instance, maybe die my special die equals new die, then we're going to call this method, and we can do stuff depending on what we want to do. So the special thing with the constructor is that we don't give it any return type, since, well, this constructor is being run, like I said, when we create the object. Well, what we return is basically the object itself, so we can't return like a string or a boolean or whatnot. So no return type, and then we just add the parameters we want here, and I'm going to give it a one parameter like that. But to be able to do that, we need to import that random thingy, the random generator. So let's do that. Import java.util.random. Oops. Like so. So we're importing that there, so now I can have that as the first, and actually only a parameter. On the slide it said I wanted the random generator and how to define the sides, but I'll show you in a few minutes why I'm leaving it out here. So what do I want now? Well, I want to set the I want to store the random generator somehow, because a parameter here, it's just going to last inside this method or with this constructor. So, well, if I have another method here called roll, then when I want to roll my number, well, I can't, because, well, the random generator is inside here, but, well, I want it inside here. So how do I fix that? Well, we can use something called a field, which is very basically just a variable. Well, it kind of is. So it's a variable that you type outside the method, and therefore it's called a field. What's good with that is that we can access it from within each method. So we can access it well, all over the place. So if I do my random generator like this, and save the random object that we get in the parameter inside my random generator, then we can use that inside roll later on. So we sort of store it for later. And while we're at it, we can create 2 other fields. So one for the amount of sides we have, and one for the current number. So here we have 3 fields. And just because, well, they kind of are variables. So, well, they are a type of variable, so therefore I'm going to type variables here afterwards, so you know what they are. And this is a constructor, which is a type of a method. But it's a special method. We have to call it the same thing as the class itself, and it doesn't have any return type at all. So it just die. Yeah, the noun. Sorry. And then we want to set the side count to 6 because that's a normal die. And finally, what do we want to set the number to? Well, we could set it to 1, for instance, or 2, or we could just roll the die once and see where it lands and use that number. So let's just roll it. So like you saw on the slide, and like you saw what I typed here before, I'm going to add a method called roll, and that's going to allow us to roll the die, and then we can get a new number. So when we create a die, we want to store the random generator, we want to set the amount of sides we have, and then finally we want to roll the die itself. But we're missing something here. We're missing the amount of sides. Well, I'm setting the amount of sides to 6, but we wanted to be able to set that ourselves. But like I said, the constructor is a type of method, and methods, well, we saw in the last course that we can do method overloading. So if we have different parameters, a different parameter list here, we can overload it with another constructor. So therefore we get constructor overloading. So then we get random, and then we get for instance sides here. So now we have 2 different versions of this, which means that we can create this object in 2 different ways. We can create it using a random generator, or we can create it using a random generator and the amount of sides. Okay. However, we can't create it like we've done before with the shell. We created the shell like, I'm just going to type it down here. We created the shell like this, like that. Yeah, it's going to print out rubbish. There we go. So we created like that. We if I compile this now, yeah, it's not going to detect what roll is, so let's remove that for now. If I compile it now, and I can refer to it from here actually to test things. If I do it like this, it's not going to work, and the reason is it can't find a constructor without any values inside here. So when we create a new die, what we give it when we create it is the parameters, and as we have with the methods, we need to match the parameter lists of a constructor. One thing that is worth noting though, if we don't have any constructors at all, which is totally fine, then it's going to create one empty one, so we can actually create one there. So if we don't have any at all, it's going to sort of simulate a constructor like that, like nothing in it. But we don't want that. We want to have these constructors because we want you to have to specify the random generator itself. So we don't allow you to create a new die without actually giving us the random generator. But if you want to, you can also specify the amount of sides on the die, otherwise it will use the default size, which is 6. Here we go, my random generator, and we do the same thing here. We store random here, and then we store the amount of sides. So the only difference here is that, oops, not that, that instead of using 6 here, I'm going to use sides. There you go. So yeah, I'm actually typing these things twice here. But if we had something longer in the constructor, we could just ask the constructor to call a method and do most of the work there, for instance, and that's totally fine. And a constructor is a method, so we could ask a constructor to call a constructor as well, but more to that in the next lecture. So then we have constructor overloading, which is a type of method overloading. There you go. Right, so now when we have the 2 constructors that we want, we have some fields that we need to operate on. Now we need these 3 methods, the roll one, the get side count one, and the get number one, right? So the roll one is quite easy. We just need to do that. So in the last course we saw that well, when you made a method use static. We saw that in the earlier example as well. When we used the share, we had like static void print share information. But now I'm not using static. I'm not allowed to use static. I'm not supposed to use it. What static does is that it tells us that this method is shared among all the different objects of this class, which means that we can just do we can use the class name and then just refer to it like that. So we use the class name dot and then just something. So if I did static void roll like this and hit compile, then if I do die.roll, then it's totally fine, because then I tell it, well, this method here, it's used globally. It's used together with all the other other instances. It's not really connected to the instance itself, so to say. But if I remove the static, it's there for one specific instance. So therefore I can't just refer to the class itself. So I can't just use die.roll because that's not going to work. And it's complaining about that. Well, I'm referring to something static there. But if I create a new die, then I can roll that one. But I can't create a new die like that, right? So if I create a new die, which is not allowed to be done like that, I need to give it a random generator. But if I would do that, I could then roll it. We'll see more examples on that later on. So static is used if we don't want it to be referred to a specific object, but if we don't have static, that's going to be well, that method is going to be specific for each and every object, which allows us to roll different numbers, because when we roll it, we want to refer to this number thingy here, which is not static either, which means that each die has its own number. Otherwise, if we had static, we can have static here, static int number, what that would do is that it would basically make sure that all dies had this exact same numbers. We don't want that. We want the different dies to have different numbers, and therefore we don't make these static. Okay, so now therefore we go void roll, and then we can set number to my random generator dot next int, so we can get the next integer like that. And what we want to do now is, well, we want the next integers of the size like that. So if I give it 6 there, for instance, if the size count was 6, then we want to get the number from 0 up to 5, basically. So we get 0, 1, 2, 3, or 5. But that's not what we want. We want to get 1, 2, 3, 4, 5, or 6. So therefore we add 1 like that. So therefore, when we roll it, we just set the number to the next integer of the different sides that we have. Right, then we want to have the other ones, the get side count, like this, and we want the return type to be an integer. And of course it's not going to be static because different dies can have different side counts, and therefore we return side count like that. And finally we want to have a method called get number, return number. Right, so what these ones do, well, they don't really do much. They just return the field's value. So why can't we just use the field when we want to refer to the side count or the number? Well, we could. There's nothing stopping us, but it's good to do it like this, because then if we refer to the die itself, then we can just, well, refer to the method and get this size count. We don't really know when we're using it. Well, we don't really care about how we get the side count. Maybe we're using this side count variable, and then we like increase it by 1 when we get a number. We might want to store it from 0 and then higher we go from 0, and then we want to return number plus 1 here instead. That would be totally fine. So what we actually have here are methods that you're supposed to use from outside of the class, while these fields we want to use from within. And that's not how it has to be. We will make later on. We will make methods that are supposed to just be used from within, and fields that can be used from outside as well. But it's good to split those things apart. What are you supposed to access from outside of the class, and what are we supposed to access from within the class itself? At the moment, you can use all of these things from the fields, and the methods can be used from outside of the class. In the next lecture, we will talk about scope, which is a way of telling us where we can actually reach the different fields, the different variables. But that's the next lecture. So at the moment, we can reach it. We can reach side count if we want to get the side count. But to make things abstract, which is better, so we just ask the die, what's your side count, and we don't care about how it's stored, then we just use get side count like that. So this is kind of our first simple class. 3 methods there, as just a comment. So we have the 3 different fields, one for the random generator, one for the sides, well, the amount of sides, and one for the current number. When we create the class itself, we need a constructor. We have two different ones with 2 different sets of parameters, and one is just the random generator. Then we store that here, and then we set the side count to 6, and then finally we roll the die itself. So we have to start somewhere, and then finally we have another constructor. We store the random, but here we actually set the sides to the amount of sides that we have, and finally we roll. And then we have roll, get side count, and get number, and that's our class basically. So let's go back to the slides here, which are resetting, stupid things. So we have these things. We need roll, we have that. Get number, we have that. Get side count, we have that. And when it's created, we need to be able to give it the amount of sides and the random number generated. As we have seen, we have that as well. But we also have something else. If we don't want to, we don't have to specify the side. So that's actually more than it says here in the specification that we had. So now it's time to create the object from it. So we have the class, which goes like public class die, and then all the code inside those curly brackets. And now it's time to create our object itself. So we use the blueprint to create our die, and to use we've seen it before. We've seen it with the share. We use new die, and then we give it the random generator. And here I'm actually creating the new random generator here. At the same time, so I use new die, new random generator, well, new random there, and then I give it 10 as the second parameter there, which means I'm using the second constructor, and gives it 10 sides. So let's see if we can implement an example with that. So we save that and go here and create public class die example. And it's still the noun. Public static void main string. Oops. Okay. So now I have this normal public static void main that is used to start the program. In a separate file is just because I want to separate the class we're using. Here to be side count, because the field is called side count. So you want to compile that. There you go. The reason why I do this is just to keep those separated. So I have the class in one end, one position, and then I have the program that uses the class in another position, which allows us to reuse the class if we want to use it for another program. We might want to create Yahtzee with it, and we want to have this example program as well using the same class. So if I started making this example program inside a class, then I would have it there as well. So it's nice to just keep them separated. And by having the void main here, it means I can run the program, right? It doesn't do anything because the main is empty, but I don't have a static void main in this class. There's no need for it to be there. So if I try to run it now, it's going to say, well, you can't do this. There's no static void main method accepting a string array. So since we don't have that, we can't run this class. But we're not really supposed to. We're supposed to write a class that we can use. So all our files doesn't have to be able to be run, but we will run them from somewhere else. So because we have a static void main here, we can start our program from here, but we can still run the die class like the code in it, but we can't start it from there. So what I want to do now in this simple example is just to create a simple die to start with. My die there, so we type and then variable name equals new die, so we create a new die, and then we need to give it a random generator. But since I'm just going to use this random generator once, if we had multiple dies, then it would be nice to just use the same for all of them, otherwise we would get some randomizing problems. But since I just have one die, I can just create it inside there. But I also need to import this, so it knows what that random generator is. So now we create this die here, nothing special. I'm not specifying the amounts of sites that we have, which means I'm going to use this constructor here, and therefore it's going to set the site count to 6. Right. When we have that random generator, we want to generate some numbers, and I want to store these numbers so we can see like how the numbers are spread out. Like, do we get a lot of 6s? Do we get a lot of 4s? Hopefully we'll get them evenly spread, but since it's random, we're not going to get them exactly evenly spread. But that's what this program is going to use for. It's going to randomize the numbers, it's going to roll the die a bunch of times, and then afterwards it's going to give us statistics on which numbers it landed on, like how many times. So what we need to do is first of all create an array where we store the numbers, and that has to be the same size as the amounts of sides we have. Because if we have 6 sides, then we can get 6 different numbers, and those 6 different numbers we have to store how many times we got them. Okay, then it's about, well, let's loop like 500 times, so we want to roll the die 500 times. That's, well, you can change that, of course. That's just, yeah, what we're going to use here. And the first thing you need to do each time is to roll the die, obviously. You need to roll it, and then we can check what number it, well, ended up with. So first of all, we just call the method there, so we do my die dot roll, because roll is our method, and well, my die is our object, but we can't do something like this because, well, first of all, it doesn't exist anything called roll here. But if I do die dot roll like that, it doesn't work either, because, well, we need to refer to a specific die, not just the die blueprint, because the blueprint can't be rolled. You can't roll the blueprint, right? You can't roll the class itself. You need the class to be, well, we need to create an object of the class and then roll that one. So we do my die dot roll, and that's perfectly fine. But we need to use the numbers as well. So first of all, we can print out what we rolled, like that. My die dot get number. Here we go. So we just get the number that is facing up, the current number basically, and that's going to be different every time because we're rolling the die. Well, it could be the same, but it's going to be changed. It could be changed to the same number, but still. And then what we want to do is get the number here. So we get the number once again, and it's not going to change now because it's just changing when we're rolling the die, not when we are accessing the number. So then we can do get number -1, like so. And what I do now is I refer to the number -1 as the index, because, well, the index of an array started at 0, remember, while the die is starting at 1, so we need to decrease it. So we get 0 to 5 rather than 1 to 6. And then we refer to the array with that index and increase that number by 1. So if we get a 1, we want to increase the amount of zeros, well, the number at the index 0 that we've had by 1. So we tell it, well, we got another 1, we got another 1, now we got another 2, for instance, and so on. So this array is going to contain all of that information. And what we can do now is we can loop through the numbers in the end. Like this, to print them all out. Number, oops, can't spell, number, and then we give it I plus 1, because I goes from 0 to 5, but we want the numbers to be 1 to 6, so we increase it by 1 now, we decrease it by 1 here. And then we tell it how many times it occurred, which obviously is random, so it's not going to be evenly like spread out between the numbers, but it should be somewhat evenly spread, otherwise we have some problems. So there we go. So now we're going to roll it. Well, first of all, we create a die. We roll it 500 times by using roll. Then we use the number here to print it out, as well as actually increasing the amount we got, and in the end we just loop through like that. Now it's rolling a lot of numbers. It's taking a bit of time because we want to print out all the results. As you can see, we get quite a large span of the numbers. We get from 67 all the way up to 96, so that's a big span. But that's expected when you work with random numbers. What we could do is disable well, printing it out each time, so it doesn't have to print out all that all the time. So now it's generating it much faster, and therefore we can like increase the amount that it's rolling. I don't know if that's how long that's going to take. It might go instantly. Yeah, there you go. So as you can see, they still are quite the same. Like we have, everyone is at 8,000, like 300, 200, 400, or something like that. But they are not exactly the same because it's random, and it seems to be working quite all right, don't you think? But since we have two constructors of this class, we can define the count of the sides if we want to, or what we did this time was not defining the sides, so we just use the default of 6. So what we could do is we can define that we just want to have a die with 4 sides. I don't know how that would look like, but yeah, we're defining that we have a die like that, and then we run it again, and now we just get 4 numbers instead. So we rolled number 1 12,468 times, we rolled number 2 12,611 times, and then a bit less for number 3, and the lowest for number 4 actually with just 12,364. So yeah, so that's totally possible. So now we made a simple die class with 2 constructors, so we can define the amount of sides if we want to, or well, here we don't define the sides, and here we can define the sides. We use 3 fields to store the random generator, so we can access that when we're rolling, the amount of sides we want to have of this die, as well as the current number that we have. Then we have 3 methods, so we can roll it, we can get the amount of sides, and we can get the number itself. So let's change this a bit, so we can change it to be 10, for instance, and then we run it like that. So all of a sudden it works with 10 sides instead, and as we can see, they are still evenly spaced like so. Right, so what if we well, we can roll the die, right? Let's change it back to 6 sides. We can roll the die, okay? But what if we want to, well, we don't really know how it's getting rolled, right? We just tell the die, my die.roll, okay, it's going to roll the die, okay? Fine. It's just doing that for us. But in the class here, we can define exactly how that rolling works. At the moment, we're using the random generator to get the next integer from the specific side count, and then we add 1 to get the numbers to start from 1 and then go to the side count instead of 0 to the number just below it. So that's how we define it at the moment, but we can define it differently if we want to. We can define it to always be 4. Like that, we set the number to 4 every time. It's a bit silly because now it's not going to work that well as a die anymore. It's just going to generate a lot of 4s. It gets 50,000 4s and nothing else. But that's totally fine. The code, as you can see, the code is still the exact same thing to use it. And that's the good part. We don't need to know exactly how the roll is going to happen. We just know that, well, if we do my die.roll, we're going to roll it. But in this case, it's a very silly roll. We just get 4s. But what we could do, we could revert back, so we get this thing here. But if we want to, we could, yeah, like increase it by well, multiply it by 2, like that, and if number is greater than where is it, side count, then we set number equals side count. So what this does is that it's going to get the highest number a lot of more times than any other number, because it's going to randomize. If we have 6 sides, it's going to randomize like if it would have 12 sides. But if it got like 7, 8, 9, 10, 11 or 12, it would just tell, alright, this is a 6 instead. So all of a sudden we have a sheet die that is going to give us 6s a lot more often than any other numbers. And we don't need to change the code in our program here itself, because that's just referring to my die.roll, and that's going to roll the die. Exactly what's happening there, we don't really know from within this example. But since we have written the class itself, we know that right now we have a sheet die here that's going to give us a lot of 6s if we have 6 sides. So if we run the program now, we can see that, well, all the normal sides here, we got around 4,000 times each, while we got the 6 30,000 times. So that's a sheet die for you. So we can do that. You can just change how the roll process is being done. But like I said, it's very nice because we don't have to change the program here itself. It's just using the die itself to roll like that. And what we could do, we could have we could have 2 versions of it. We could have like if is sheeting, then we could have oh, oops, what did I do? Here, this should be up here. So if we're sheeting, we want to generate it like that. Otherwise, we would want to generate it like this, for instance, the normal way. So if we're in sheet mode, then we want to roll it like this. Otherwise we don't. And we could have like a boolean here is sheeting like that, and we could overload it once again. So we could have another constructor here to overload it once more, where we have well, we could have like boolean is sheeting here, so we can define that. So that's one option. But the option I'm going to do is actually add a method here, a void method, set is sheeting, for instance. Well, activate sheet mode. There you go. Activate sheet mode. So if we do that, this die is going to be a sheet die. Sheet is sheeting like that. So we set that to true, and we hit compile. So now if we create another die, or what we could do is the following. So we can add a method here. And that's going to be static because we don't refer to a specific object here. We don't refer to a specific object of die example. And now if we do static void roll die example, so and then we want to do that for a specific die. We give it a die and then my die. So now if I put this part here, this thing here, if I put that inside here, then I can just call that method, and it's going to do this roll example for that specific die. So if I create this random generator now here, so let's do it like this. And the reason why I do that is so I don't use the same, well, 2 different random generators, because if I create 2 different random generators at the same time, they are sort of going to generate the same numbers, and therefore the pair of die says is not going to give me unique result. They are sort of going to be the same. So what I want to do is create die number 1 here with the random generator, and then I want to create die number 2 here like that, and then I want to do die number 2 dot activate sheet mode like that. So as you can see now, I create 2 different dies, and then I activate sheet mode for 1. So we have a blueprint. We can create how many dies we want. It's fine. And then we can do roll die example, and then we use it first for the first die, and then we use the second die like that. Hit compile, and then we run it. So the first time it's going to be evenly spread out at about 8,000, and the next time it's going to be about 4,000 equally spread among the numbers 1 to 5, but the 6 here is going to have a lot of more. And it's still going to work if we do like 10 sides, because as you can remember, we didn't specify anything specific in the rolling here. When we're sheeting, what we're doing is we're just randomizing more number. Well, we have the double the amount of numbers that we can use when we're randomizing a number. But if the numbers is outside of the range of the die, if we have like 20 when we just have 10 sides, then that's going to count as a 10, the highest number. So now if we have that one instead and run it, we're going to see the same thing. We have them evenly spread at around 5,000 with the normal die, and the sheet die we have around 2,500 at the 1 to 9, while 10 is rolled 27,000 times. So there we go, a very simple example. We expanded the die to be able to activate the sheet mode with a fourth method. So we have 4 methods there, and we have 4 fields. And then we use the isSheeting here to be able to randomize numbers in a different way, so we got a lot of the highest number there. So that's about what we're going to go through today. So let's see what we've been talking about. First of all, we spoke about these blueprints, which is what builds up object-oriented programming, and they are called classes. So we have a share there to the left and a die to the right, and they specify how these objects are being created. If we want to create a share, then we can use the blueprint to tell us, well, what do we need, what can we use it for, and so on. We use this share to create our first object, and this object can then be well, we could sit on it, we could well, it could break it down. We added that after a while, and it could have different colors. There you go. We have the isOccupied, getOccupiedBy, setOccupiedBy, and setUnoccupied, and these are different methods that are specified in the blueprint. And since they are specified there in the blueprint, we can use them with the actual share. Of course, the blueprint can't be occupied, so we can't use isOccupied on the blueprint itself, on the class itself, but on the object, the share that we created, we can ask it if it's occupied, we can ask it who's occupying it, and so on. And of course, if we have an office, we want to have multiple shares, and if we have a blueprint on how we can create one share, there's nothing wrong with just creating multiple versions of that blueprint. So when we have written our blueprint, our class, we write the class once, and when we have done that, we can easily just use it multiple times. So that's the beauty of object-oriented programming. We write the class, and then we create a lot of objects. But of course, when we have a blueprint, we don't have to make all the objects exactly the same. If we in the constructor specify different parameters that we can apply, then we can create them differently. So in the case of the shares, we could give them a specific color, and in the case of the die, we could give it the amount of sides, for instance, and we had to give it to random generator to randomize it with. So when we create a die, we give it those two things, and then it's going to work depending on what we gave it. And the shares, we could also give it the color, like I said, and then we printed that out, if you remember. And finally, we have this little slide here. We have the class itself. To the left there, you type public class die in this instance, and that's going to define the blueprint. That's going to tell us how a object is supposed to be created, what methods do we have, what fields are being used, what constructors, like how do we create it all. And then when we use that, we can create the die itself, where we can actually use these methods. So if a method is static, we can use it in the blueprint, so there to the left. But if it's not static, which is the more common thing to be, then we have to create an object and then use it on the object itself. So as you can see there, we create a new object with a new die, and then we give it a random generator. So we create an object called well, a new random object as well, and then we use 10 sides. You've seen this slide before. And then I'm just going to go through this again. Now we can go and take a look on the site. It's going to be uploaded in about 3 minutes, I think. It's automatically going to be uploaded. And it's a questions and exercises document, so you can do the questions to see if you've learned what this lecture is about. So it's some questions about some small things about well, classes basically, and some keywords and stuff like that. And then you have answers to that in the end of the document. So when you've done it, you can just scroll down and see if you had the correct answer. It's going to be a sort of short description about why the answer is correct, and so on. And then there's the exercises, which are programs that you're supposed to write. The current programs are well, in this first lecture we have one that you're supposed to write a person class, and one where you're supposed to write an occupations an occupation class that you're going to use for some other things, for some salary calculation and stuff. And then there's possible solutions to those, and remember that, well, when you write a program you can do it in many different ways. So there's not like one correct way and one wrong way. There are multiple ways that works and tons of ways that don't work. But so if your solution works, then it's fine. Then it's probably a good solution. And then we have the further explorations. Those do not have any answers. They are just there if you want to continue and explore a bit further. And in this case, in this lecture, the further explorations is to combine the share class from this lecture, the person class from exercise 1, the occupation class from exercise 2, and put that together with a meeting class. So you can have a meeting, and then you can have different persons in them, and then you can check their occupations and see if they are in the board. If you have a board meeting, you don't want any non-board members there, for instance. So that's the further exploration one. That's a bigger one without any answer, which you can do if you want to continue further on. So that's about it, actually. This has been Thinking with Objects, lecture number 1, Introduction Introduction in Classes. I've been VSWE, and I thank you for watching, and I hope to see you next time.